Hello and welcome to OOPS, Object-Oriented Programming. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. In this, we're going to cover a basic understanding of object-oriented programming, and we'll be specifically working in the Python interface, or the Python code. OOPS, the basic concept, is not the accident you just had or the mistake you just knocked your coffee cup over off your desk, but it actually stands for Object-Oriented Programming. And whether you're working in Python, which we'll be doing today, or in any scripting language, almost all of them rely on object-oriented programming as their basis. Programming paradigm that focuses on objects. So everything is an object in the coding. Every instance in Python is an object. And again, this is true for any of the main programming languages. If you're working in Java or Scala or any of these, you're going to be looking at object-oriented programming. It just makes a lot of sense and really is one of the cornerstones of today's programming. And when we talk about object in programming, an object has two different things. It has two different things: attributes, which is data describing the object, and behavior, methods on the attributes. So the first one is your actual data, and the second is what are you doing to that data. And if you're a car lover, we're going to use cars as an example. This is kind of easy to see how that might fit into the different objects. And so we're going to start with a BMW, for example. That's an object. And with the BMW, you might have like the year of the manufacturer, maximum speed. Those would be attributes of that car. And then you have the behavior. These are methods on the attributes. For example, you might display the speed or change the speed. So even though you have a maximum speed, you might have current speed also, which changes depending on what you want it to do. Step on the accelerator, go faster. Step on the brakes, go slower. And the primary terminology in programming is usually class, and that's definitely true in Python. So class is a collection of similar objects. And in this example, we have car as our class. So you might have trucks, bicycles, and airplanes. But in cars, we have some very specific things. Cars have four wheels that are on the ground, maybe a spare hanging down, headlights, steering wheel, things you would expect in a car. Doors to get in, so it's all inside. And in here we actually have a number in the collection. We have our BMW, our Ford, our Audi. You can guess the guys in the back like the BMW the best. I don't blame them. And so we work with classes or a collection of items. Today I'm going to use the user interface PyCharm. It's one of the very popular Python editor. I myself have never used it, so this is a new experience for me. It's pleasantly fun to use and easy to set up. You can go to jetbrains.com. That's the people behind it. So www.jetbrains.com/PyCharm/. And once you're on the PyCharm, if you go under downloads, you'll have two options. Let me just hit the download now button. It'll take you to the two options. One is the professional, which you would pay for, which allows integration between teams and company setup, and has a bunch of extra cool tools that you need for a business. And then there's a community version, which is the lighter weight one. For the purposes of this demo and most of the work you do, the community one's probably just fine. You can download it. It's open source and it's free. I don't know about you, but I like open source and free on a lot of my stuff. And I've already opened up a project file, but you can create a new project file up here. Put a note down in the YouTube and they can send you some of this code, or go visit Simplilearn. They'll send you the code itself if you need it. There's a lot of different, like I said, functionality in here. We're mostly going to be underneath just run the demo. In this case, I'm doing OOPS Simplilearn, so we'll just be running what I'm working in here. Let's go ahead and start with creating a class in Python. And you simply just tell it it's a class. So the class means this is going to be our Python template, whatever we are working on. And we'll call this car. And this is interesting because class itself, let me just highlight that. So when I put up class here, that is a Python object, and then I'm using that to build car, my class, specifically on here. And let me go ahead and just change that font. I have it pretty large already in my editor. Let's go back down here to editor. Font, and I put it up all the way to 26. I think we can get it by with 30 so you can really see it. Hopefully that's going to be big enough on there. And so once we have our class, we want it to do something. And so in a class, when you put the words def, that stands for definition, whatever that's called, that is a function. It's going to actually do something on there. And you'll see what I like about this is nice. With PyCharm, it automatically puts self in there. Why? Because self refers to whatever the object is. Now it doesn't refer to the template class car, it refers to the instance of that. And I'll show you in a minute what that exactly means. But in this case, we're going to do something simple. We're just going to have it print, and you can see it automatically indents it. So Python, if you remember, or if you're new to Python, is based on indentations. You have to indent. So everything under this indent is part of the def. Everything under class that's indented is part of the class. And so we're just going to look down at our speedometer, and we're going to print 155 miles per hour. Maybe it's on the Autobahn in Europe, I don't know, racetrack. Not very often you go 155 miles an hour in a car, at least not in my experience. Maybe in the future we have auto cars that do hundreds of miles per hour and shoot down the freeways. And let's go ahead and create an instance of the class, and we'll simply do BMW equals car. And we'll put brackets on there. And let's also do, let's do a Ford. Ford equals car. So if you remember, car is like a template. It's still an object. So I have BMW equals car, and I have Ford equals car. These are two separate instances. So they're copying, or they're actually putting a pointer to car. So everything under car is part of BMW. And the same thing with Ford. And we can do something like this. We can go car dot get speed, and let's put in the BMW there. Or we could also do car dot get speed Ford. Given the choice, I think I'd go with the BMW. And there's another way you can do this. We can also do BMW dot get, because remember it points back to the original template, so all the functionality is in the original template. And then we could also do Ford dot get speed. These are a little bit more common, more than you'll see the top part. But let's go ahead and run this. And if we go under Run, we find out that Alt-Shift-F10, you can use the hotkeys, which I'll probably start doing. And I just simply hit, make sure I highlight the one I'm working on, and it runs it down here. And so you can see right here we have 155 miles per hour printed out by the BMW, 155 miles out printed by the Ford, car get speed, and then I did it in a different format, BMW.getSpeed and Ford.getSpeed. The thing to notice is the term self. That is a Python term, which means that when we create an instance, whatever comes in here is what's being processed. And so if I call the class or the template directly, in this case I did car get speed, I have to include what that self is. In this case it's a BMW. Or if I'm calling it from the instance BMW, because it includes the car class, it knows that get speed, and it knows automatically that this is self. And that's where the term self comes in. So that's important to note in there. In Python, that's one of the more Pythonic kind of solutions, is that when you see the term self, that refers to that instance that you created. In this case, the BMW instance and the Ford instance. When you're setting up a class, there's a lot of things you can do in here. There is a key term, init. What this means is that when I create the new instance, whatever happens in here is going to be set. This sets up your information. Let me show you how that works. And what we're going to do is we're going to pass year and speed in here. And this is really important, is I need to take self, that's going to be the new instance I created. In this example, it'll be our BMW and our Ford. And put a period here, and then year equals year. That's the variable that was passed. And we'll do the same thing with speed. Self.speed equals speed. So when we create this, we now have two different variables in here. And if you remember from our slide, an object has attributes, data describing the object, and a behavior, methods on the object. And so in our class or our template, we're going to initialize it with the year and the speed on here. But if we initialize it here, when we create the instance, we have to send that information so that it knows what the year is and what the speed is for the BMW and the Ford. And that means when we create this instance, let's go ahead and do 2018. Maybe this is the maximum speed that shows up on the speedometer, I don't know. But 2018, and we'll put it at 155 miles per hour. And then we'll take the Ford, a little bit older, runs a little slower. It's a 2016. And this will be the maximum speed. We'll do 140 miles per hour. That's the fastest it can go. And then, so now we've set up some data on our object right here coming through. And so BMW now has a year and a speed, and so does Ford. And when we get speed, let's go ahead and change this. And in fact, I'm going to do, let's just get rid of this middle part, because I tend to do the standard BMW.getSpeed. and we'll call this maximum speed. Maximum speed is, and then we'll just put down self speed. So that's our variable. So that's whatever the instance is. So self speed is going to refer to our BMW or our Ford. And if we go ahead and run this, and that was, we can go up here to run and Alt-Shift F10. I'm just going to do Alt-Shift F10. It's already set to the tab I'm on. Hit Enter. And we come down here and you can see, had an error there. This is a double underline for the init. The code that they sent me had just a single, and I forgot to double check that. So we have a double underline init. It comes in year and speed. The BMW has 2018 with a maximum speed of 155. And when we print that out, BMW get speed, you'll see it right here. The maximum speed is 155. And then it does it for the Ford. Maximum speed is 140. And then we're done processing it. So we stored some data in here. We stored the year, we stored the speed, and then we've had a process on that data, and that is to go ahead and just print it out. Print out the self.speed. And let's go ahead and briefly look at encapsulation. Def set speed self speed. So we're going to send it a new speed value to set the speed. And from here we'll go ahead and do self.speed equals speed. And we'll just work with the BMW on this one. Let's take the Ford out of there for a moment. And we have our Ford get speed. And then we're going to set the speed. And the new speed is going to be, let's make it 143. Just an odd number so it's easy to see. And then we'll go ahead and do BMW.get speed. And when we go ahead and run this, I'll do the Alt-Shift F10 and run it. As you can see here, it comes out and says 155, because that's what the speed was when we first entered it. And then we went ahead and changed it. BMW.setSpeed, and is now 143. So you can see here how we can alter the information in our template. And if we remember, we had the Ford is completely separate from this. So if we still had Ford down here equals car 2016, 140. If we still had that down here, this 143 isn't going to affect the Ford at all, because this Ford instance is separate from the BMW. So if I do Ford.get speed, and we do an Alt-Shift F10 to run it, there we go. Here's our Ford, 140. So it hasn't changed even though we set the speed on the BMW to 143. The first thing we want to look at is inheritance. And so inheritance is a mechanism for a new class to use the features of another class. And if you've ever done like word processing, you might use a template. From that template, you can have all kinds of stuff you put into the template, and you can save it in different instances depending on what you're doing. And then those particular instances you saved could be used as a template for your next thing. You have a class, and from that class we can inherit everything from there and then make changes on it. And then we're going to go ahead and cover, let's do this. Ford BMW, just close that up. Take this out of here for now. Okay, let's go ahead and do inheritance. That's where we're going to take the class car, and we're going to bring all these features from class car into a new template or a new class. And let's start with a class sedan. And the sedan is going to inherit from car. So it's going to bring car in, and now we have a sedan coming down. Once we create the sedan, this is now a child class to car coming down. And under this class, I'll just go ahead and we'll just type in a def accelerate. Of course, self. And on here, we're just going to have it print. And let's have it do 150. That seems like very high. Let's go 133, just because. I don't know why I like the 133. Let's change it to 137. There we go. And then let's do another one here. We'll do this class SUV, and it also is going to inherit from car. And this too is a child class of car, so we'll just put a label there so we can remember that. And we'll also give it an accelerate. And when we do an accelerate, keep the self, and we'll print, let's see, this year, whatever production is 180. I don't know why. That seems awfully high for an SUV versus a sedan. Let's do 127. The SUV goes a little bit slower than the sedan. There we go. So let's go ahead and hit enter on there. And let's take a look at what we got going here. I have my BMW. I have my Ford. And let's add a Honda, and we're going to make it equal to the sedan. And just for fun, let's add one more thing. Def open trunk self, and we'll put print trunk has been opened. There we go. So let's take a look and see what we got going here. I've created my Honda. And if you remember up above, we have our BMW. And I'll just do just the BMW. Get speed. And then I want to do the Honda get speed. And when we run this, we can see our BMW is 155. And our maximum speed on our Honda is 150, because that's what we set. Now remember, this inherited it from cars. So this init is now part of the sedan. The open trunk, if we do this, if I go the other way around, let's say, oh, let's do this. Let's do the Honda open trunk. And then we'll do, just to throw an error here. This is going to give us an error. It doesn't even auto type it for me. So we'll do Alt-Shift F10 and run it. And you can see down here is that we had our BMW get speed. Okay, there's our 155. We had our Honda get speed. We had our Honda open the trunk. And because our car, when we go up here to car, does not have open trunk, the BMW does not have that definition. So it gives us an error. So we can't do that unless we add that to the top as part of a car. It just turns out though that, let me just take the BMW out. For whatever reason, this BMW doesn't have a trunk. I think they all have trunks, but that's okay. For this example, we'll just leave it like that. So you can see right here, we've inherited, and then we've gone ahead and added new features to our new class. So this child class of sedan has come in here. Now it has both accelerate, open trunk. The SUV, which we're going to look at in just a second, also has open trunk. So we've had a lot of functionality. We have our original car template, so whatever's set up here comes down here. And then we've added both accelerate. Let me just do that right here. Our Honda, we can accelerate the Honda. And if we run that, you can see the Honda has their acceleration come in and prints out. In this case, 137 down here. That's why I like to mark it with a weird number like 137, so you can tell the difference where we're going. So we have our accelerate. So we've added features into our sedan. Encapsulation is an important feature, preventing data from direct access. This is what we call encapsulation. We'll discuss that more later on, but what it means in this particular case is that when you create a class from another class, you can't alter the original template. The child class can make all its own changes to that class and do all kinds of things, but it can't make any direct changes to the parent. Let's go ahead and take a look at encapsulation in the code itself so we can have a better idea of what we're talking about. And so we have our class car, and we have our definitions. Here's our init. This is from, if you remember from the last slide, we had our init. Maybe we add a couple more functions to it or modules to it, and we have get speed and set speed. All of this under class car is encapsulated. What that means is that if I create an instance of it, in this case I'm going to create a BMW. Wouldn't that be nice if I can just whip out a BMW and make a BMW? When we create our instance BMW, it does not change the class car. This, whatever we do to this instance, does not make changes to our class. And the same thing with the Ford. The BMW does a get speed. It might do something here in the definitions under the class, but the initial class, if I create another car, let's say we take our BMW and we set the speed for 155 like we did here, and we create a Ford, whatever I do with the Ford does not change the class car. And if I create, like we did before with our inheritance, a subclass, that's not going to change the class car. That's what they call encapsulate. It bundles things together, and it really is central to OOPS, object-oriented programming. Is we're basically bundling things together, and then we keep them in a nice safe bundle. And anything we do from that, we either point to it and say, hey, let's use this definition, or we make a copy of it. So we kind of do a combination of there and say, okay, here's our new inheritance. But you can see right here, this is encapsulation. And again, that's like central to OOPS. This is how OOPS was originally discovered, created, and founded, is when they realized, hey, why don't we just bundle things together instead of rewriting the code over and over and over. And then polymorphism. We talked about encapsulation in classes just recently. Like I said, we'll go in this and when we open up the code. Polymorphism is we take the feature in the code and then we can alter that feature. So we can use the same function in multiple ways. That's a lot of fun, a lot of power in that. Let's go ahead and take our polymorphism and take a look at it, what's going on in the actual code when we're writing our Python code. So here we have our parent class, car, and we switch colors. Here we have a sedan, where we inherited the car, and an SUV, also an inheritance. And when we look at this, we have up here our init. So let me just so we have our definition, we're initializing it. The first class, we've added in accelerate. So what that means is with our acceleration, that's not part of the initial car class right now until we add it in. So we have our definition accelerate, which print 150 miles per hour. So all sedans have a print of 150 when you do accelerate. All other cars don't have anything going on in them right now. And then with SUV, we're going to define the accelerate differently. So we have the accelerate down here with self print 180. So we have two different polymorphs going on here. We have one polymorph going on in this example. We've added accelerate to both of these classes. And so it doesn't matter which one I accelerate, is going to do something. And so if we create, in this case, we're going to create an object down here, an instance of it. Do this in pink. Here's our instances. Oop, that's a little light. Let's do something a little darker than that one. There we go. So we have our instances, and we're going to create one object, which is a sedan, a Camry, and one object, which is an SUV Scorpio. And then we can just go through the objects. We can actually just loop through the objects, one object at a time. And if we do print object name and end, we have our object name. So it's going to print the name. In this case, it'll print Camry and it'll print Scorpio. And then we have object accelerate. And for the sedan, since that's our Camry, it's going to print the 150. And for the SUV, it's going to print 180 for the Scorpio. And so by doing this, we polymorph the same definition to do two different things depending on what our child class is. So we can polymorph all kinds of things, and we'll actually look at a couple more objects in there when you go through the full code later on. There's a couple more examples in this. But this is a polymorphism coming down, and you can see how we're able to leverage the same name for the definition to do different things depending on what our object is. Thank you for joining us today for OOPS Object-Oriented Programming by Simplilearn, www.simplilearn.com. Come join us, check out the classes. Feel free to join our forums and post questions you have on there. Or if you have questions on this video, you can post them down below in the YouTube comment section, and we will be monitoring that. Again, thank you for joining us. Happy learning and have a great day.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.